For 160 million years, dinosaurs ruled the Earth. They endured shifting continents, changing climates, and countless challenges across deep time. For so long, their dominance seemed almost permanent. But around 66 million years ago, an event from deep space changed everything. A massive asteroid struck Earth, carrying enough energy to transform the planet forever. The impact did more than carve a colossal crater, it triggered a chain of global environmental changes. And the most dangerous part wasn't the outer itself, it was what came after. From that moment forward, the world once ruled by dinosaurs began its final chapter. In the aftermath of the impact, an enormous amount of material was blasted high into the atmosphere. Molten rock, dust, and debris spread around the planet, reshaping the sky itself. As gravity pulled this material back toward Earth, streaks of glowing fragments illuminated the atmosphere for hours. This was not a brief meteor shower, but a prolonged storm of falling fire across the globe. The resulting heat rapidly altered environments. Forests began to ignite, and atmospheric waves carried warmth far beyond the impact site. Even regions thousands of kilometers away experienced these changes. Temperatures rose, skies glowed, and ecosystems entered a state of unprecedented instability. This was no longer a local catastrophe, it was a planetary event. Across continents, animals lifted their heads toward unfamiliar skies filled with drifting embers. Daylight blurred into a glowing haze as particles continued to fall through the atmosphere. And while the fires eventually faded, the planet itself was far from recovering. After the fires began to fade, a quieter but more profound transformation unfolded. Dust and aerosols from the impact spread throughout the atmosphere, forming a veil that dimmed sunlight across the planet. Days grew darker, and familiar rhythms of light and warmth began to shift. What once felt like a brief aftermath was becoming a prolonged global condition. With reduced sunlight, photosynthesis slowed dramatically. Plant growth weakened, and ecosystems that depended on stable energy from the sun began to destabilize. Across forests, plains, and coastal regions, landscapes entered a period of uncertainty. Food sources declined, migration patterns changed, and survival became increasingly complex. Temperatures gradually dropped as sunlight struggled to reach the surface. The planet that had recently burned now began to cool. For life on Earth, this new phase would prove just as challenging as the impact itself. A world once filled with warmth and abundance was transitioning into one shaped by darkness and scarcity. And as the weeks turned into months, one truth became unavoidable. When plants begin to fail, the entire food chain starts to fall with them. As plant life continued to decline, the effects began to ripple across entire ecosystems. Large herbivores that once roamed landscapes rich with vegetation now faced a growing scarcity of food. Migration became more frequent as animals searched for remaining sources of nourishment. But across many regions, greenery was becoming increasingly rare. For species dependent on constant grazing, even short interruptions in plant growth created significant challenges. Energy reserves dwindled, populations weakened, and survival grew uncertain. Predators soon felt the consequences as well. With fewer herbivores to hunt, competition intensified and hunting success declined. The balance that had defined these ecosystems for millions of years was slowly unraveling. Extinction was no longer a distant possibility, it was unfolding as an ecological chain reaction. Across continents, once dominant species struggled to adapt to rapidly changing conditions. Habitats shifted, behaviors altered, and long-standing ecological roles began to disappear. For some animals, adaptability provided a temporary advantage. For others, the pace of environmental change proved overwhelming. The decline of food webs did not occur in a single moment, but through countless individual struggles repeated across the planet. Each day brought new losses, gradually reshaping the living world. By this stage, the extinction of dinosaurs was no longer driven by the impact itself, but by the cascading environmental changes that followed. Yet despite the widespread devastation, Extinction was not universal. A number of species endured the dramatic environmental shifts that reshaped the planet. Understanding why some survived while others vanished reveals an important pattern in Earth's history. Survival was often linked not to strength or dominance, but to flexibility. Many of the animals that persisted were relatively small. Smaller bodies required less energy and allowed individuals to endure longer periods without abundant food. In contrast, large animals depended on constant access to vast amounts of energy. When ecosystems faltered, this dependency became a significant disadvantage. Habitat also played a crucial role. Species living in aquatic or semi-aquatic environments experienced more stable temperature conditions than those fully exposed on land. Some animals possessed metabolic strategies that allowed reduced activity and energy conservation while conditions remained unfavorable. Dietary flexibility further increased survival chances. Omnivorous species capable of consuming varied organic material were less vulnerable to the collapse of any single food source. Shelter offered another advantage. Burrows, underwater environments, and other protected spaces shielded animals from surface-level extremes. Meanwhile, dinosaurs, despite their extraordinary evolutionary success, were often more specialized. Large body sizes and specific ecological roles limited their capacity to adapt rapidly. As conditions shifted beyond familiar thresholds, their populations declined and extinction gradually spread across lineages. Yet among dinosaur descendants, one group quietly persisted. Small feathered dinosaurs survived through the upheaval, eventually evolving into birds, the only living lineage carrying the legacy of dinosaurs into the modern world. As time passed, the dust that had shrouded the planet slowly began to settle. Sunlight gradually returned, illuminating landscapes that had endured years of transformation. The recovery of life did not occur suddenly, but through quiet and persistent renewal. Among the first to reappear were hardy plant species capable of surviving extended environmental stress. Ferns, mosses, and resilient vegetation began to spread across once barren ground, restoring the foundations of terrestrial ecosystems. Insects followed, then small animals emerging cautiously from sheltered habitats. For countless generations, life rebuilt itself step by step. The world that emerged was familiar in shape, yet profoundly altered in structure. Without dinosaurs dominating ecological roles, new opportunities appeared across land, sea, and sky. Among the survivors were mammals, small, adaptable creatures that had persisted through the crisis. Over vast stretches of time, these mammals slowly diversified, exploring environments once inaccessible to them. Forests, plains, and oceans became arenas for new evolutionary experiments. Within one lineage, enhanced cognition and complex behavior gradually emerged. That lineage would become humanity. The extinction of dinosaurs stands as one of Earth's most dramatic transitions, not simply an ending, but a turning point in the story of life. It reminds us that planetary ecosystems are dynamic, shaped by forces both internal and cosmic. And as we look back across deep time, one question quietly remains. If a world ruled for 160 million years could change so completely, what transformations might still lie ahead for our own?